This lesson is on series and parallel circuits. If you recall from previous lessons, circuit elements can be configured in either series or parallel formations. A series circuit is configured in such a way that total circuit current flows through every component wired in the circuit. As you can see by the red arrows, current leaves the source and flows through the light back again to the source. There is no other path for current to flow. I can control this by using a switch, which is again wired in series. Current flows through the switch. If the switch is open, the circuit doesn't come on. When I close the switch, the light comes on. Let's demonstrate that. I have a light and a switch. Now I've wired supply coming in through the switch, wire coming out of the switch through the light, the other side of the light back to the supply. When I turn the switch on, light comes on. When I turn the switch off, light comes off. Turn it on, notice the brightness of the light. Now, I shut the switch off and I want to add a second component, another light to the circuit. We're going to connect one end of the light from the first light through the second light. Connect this up to our supply. Turn the switch on. Both lights come on. Notice the brightness of the lights. They're a little dimmer than when there was a single light. One of the key facts of a series circuit is that current flows through every component in the circuit. So current is the same through every component in the circuit. Voltage is not. As you run current through each component, there takes a certain amount of voltage to push that current through each component. As you add more components to a series circuit, you reduce the voltage available to each individual component, and that is manifested by a dimmer light than when you had a single light. Now, if I disconnect any wire in this circuit, both lights are going to go out. That's the Christmas tree effect. And then once again, that's a factor or a key fact about a series circuit, is that at any point where if you were to break that circuit, all the lights or all components within that circuit will no longer have electricity or current flowing through them. So let's recap some of the key factors of a series circuit. There is only a single path for current to flow. All components in the series have the same current. All components divide the voltage among themselves. The sum of all the voltage drops across components equals the total of the supply voltage. Next, we're going to move on to parallel circuits. Parallel circuits are designed in such a way to allow multiple paths for current to flow. As you can see by the red arrows, as current leaves the source, it reaches a junction or a node and is divided. Some current flows down this branch, some current flows down this branch. Then it reaches a recombination node where the current recombines and then returns back to the source. One of the factors about a parallel circuit is the current drop across each branch. The sum of the current drop across each branch is equal to the source current. Another factor of a parallel circuit is the voltage within a parallel circuit is equal to the source voltage. So it differs from a parallel or series circuit in which current was the same through each component and voltage was dropped. In a parallel circuit, current is divided amongst each branch and voltage remains constant across all the branches in a parallel circuit. Now I've added a schematic here with a switch, and we will wire it up and show you how a parallel circuit works. So here is my switch. Here are my two lamps, and I am going to wire my switch. If you've noticed, my switch is in series. Now I'll get to my first lamp, which I'll put right here, and this point is where we call the node. From here, current is divided to each lamp. Alright, I think I have it wired up here. Let's turn our switch on and see our lamps. Now, one thing you can notice is that both these lamps are just as bright as when we showed the series circuit with a single lamp. That's because the voltage is the same. We're using a 24 volt supply, and each lamp is receiving 24 volts. Another factor or key element of a parallel circuit is if I were to disconnect one of the wires on a branch of the circuit, only one light goes out, not both lights, as you can see here. So I can open one of the branches, and that will not affect any of the other branches in a parallel circuit. So let's recap some of the key facts on a parallel circuit. Each branch provides a different path for current to flow. All components have different currents. The sum of the current drops across each component equals the total circuit current. Thank you very much for listening to my series in parallel circuit lecture.